I didn't know it said that. Good morning, afternoon. I don't know what time it is. Ladies and gentlemen, how are we doing today? So obviously, I am not available today. So I want to kind of talk through what I want you guys to complete today and give you some examples, kind of walk you through it, maybe talk over some points that might be kind of tricky for us that we might have problems with, just to kind of clear things up before you just get into it and kind of have no idea what to do. So let me share my screen with you and we'll talk about the assignment that I have for you today. All right, so in Schoology, boom, we have, this is physics honors. That was already on physics honors. I don't know why I clicked on that. All right, so today, what I want you guys to do, it's over on the right-hand side here, virtual lab, constant acceleration with the moving man. It's got the purpose and everything. I'm going to kind of walk through this so you guys have something kind of base what we're doing off of. I want to do today at 11:59. I think you guys should be able to do it. It's not super complicated. You should be fine to do it by today, probably even in the period that we have class. So purpose to examine the motion of an object undergoing constant acceleration, right? So most of the stuff that we've done so far, we've been looking at constant velocity, where the velocity is not changing. Today, I want you guys to use this app to look at some motion where the acceleration is changing, or we have acceleration, so the velocity is changing. It's not constant velocity. So we have the applet. The link is in the assignment here. It's also in the Word document down here. So whichever one you choose to use, the link is there. So if we click the link there, it should take us to this PhET simulation, which is called the Moving Man, right? That's why it's the Moving Man Virtual Lab. So you can do it, computer. Here it is, right? This is our Moving Man simulation. This is what we're going to be using. What will you need? Sketches of graphs of motion. We'll talk about that in a second. Answers to questions about the motion. That's pretty easy. And the answers to the analysis question. 30 points. Here's our rubric that you can see is being used to grade it. And our Word document at the bottom here. There's also a PDF if you want to print it out and use it that way. But I don't think you can edit the PDF, and I think editing is going to be kind of important here. So open up the Word document. Again, same instructions that we see in the assignment itself, right? Up to the grading part. Again, another link to get to the video or to get to the application. Video if you need some instructions on how to use the application, but I'll be showing you guys that right now in a second. So we have the procedure here. It walks you through the procedure. I'll talk through that as well. And then these are each of the trials where we're going to be sketching things and answering questions and answering analysis questions. So there are 7 total trials. Shouldn't take us that long to get through them, I don't think. And then 3 analysis questions to go along with those. So looking at this, that needs to be moved over a little bit. This needs to be moved over a little. Like I said, I want to walk you through the first couple steps of the procedure to make sure we're all on the same page and we're all good. So open up the Moving Man app on the PhET and click the Charts tab at the top. So I have the Moving Man open right here. And up in the top corner, right now we're in the introduction panel, right? The introduction part. We want the charts part. So I'm going to click on charts right there. And it'll pop up. I've got a position chart, position versus time graph, velocity versus time graph, and acceleration versus time graph. We haven't talked about acceleration time graphs at all yet. So those are pretty new to us. But we've talked about position and velocity graphs. So those should be pretty straightforward for us. And we're really, the goal of today is to just look at the graphs and see how the graphs match up for the same type of motion. So we don't really need to know the specifics. So click the red X at the top of the brick walls. We don't want the brick walls to be here. There's an X here or an X on the other side. If you click either one, the walls will disappear, right? We don't want the walls there because that will stop the motion and then we won't be able to see what's going on. So, or it'll stop the man and our graph will end, and we don't want the graph to end. So we want to get rid of the brick walls. In the bottom right corner, click the plus button on the magnifying glass to adjust the time range on the x-axis. We want the time to display just from 0 to 4 seconds. So you see the plus down here. It's a little bit hard to find on the actual application because there's a plus minus here, a plus minus here, a plus minus here. These ones are for the graphs themselves for the y-axis, right? From 10 to -10, 12 to -12, 60 to -60. That's what these plus and minuses on the side are for. The magnifying glass in the very bottom right corner is the one that changed the time scale. So this bottom corner, right, I'm going to click on that one. And we're going to click that until this time is 4 seconds. Right now it's 14, 12, 10, 8, 6, 4. So now my time scale is 4 seconds. All right, so I get a little bit, we're not working with as much data as we were before. On the left side, you can see you can set the initial position, initial velocity, and the initial acceleration. Those will be stated in each trial, right? It says trial 1, initial values, position 0, velocity 0, acceleration, or sorry, velocity 2, acceleration 0. So that's what we're going to use to set those initial velocities, right? Position 0, velocity, I can type in 2, acceleration for the first trial was 0, so we leave that there. So the left side, the boxes, that's how you change the initial settings, which is what is stated, what's different about each trial. All right, so that's there. Set the position, velocity, and acceleration to the values in the first trial or second trial or third trial, right, whatever trial you're on. Then hit the play button, allow simulation to run for 4 seconds, watching the motion, hit the pause button. So here I've got my setup for the first trial, press the play button. It actually runs in slow motion. I don't know why it runs in slow motion, but it does. So it takes more than 4 seconds to get to 4 seconds. But you can see here, I'm at 3 seconds and 4 seconds. All right, so I let the motion run for 4 seconds. Then I press the pause button. We go back here. Draw the sketch of the graphs. We might need to use the plus minus magnifying glasses on the side to see our graphs. We might need to do that. And then when we finish, we can press the clear button to reset the simulation and enter new values for our position and velocity and acceleration. And then we just repeat steps 5 and 6. We set the position for trial 2, press play, watch the motion, set it for trial 3, press play, watch the motion, and then fill in the graphs. So let me show you how to fill in the graphs. And this is, this part's a little bit tricky, so I do want to talk to you guys about this part. So create a sketch of each graph and answer the questions. You can use the insert feature or the draw feature to do this. So this is why I have this as a Word document. And I think a Word document is definitely the easiest way to do this. I know you guys like to use Google Docs, but I haven't found a really easy way to do this part in Google Docs. Google Docs, it lets you do the drawing, but it won't let you put the drawing over top of the graph, right? It wants the drawing and the graph to be separate things, so it won't let you kind of merge them there. So if you're going to try and use it on Google Docs, you might have to be a little creative. And I'll show you the one kind of creative way that I came up to do it if you want to use Google Docs, but we'll get to that in a second. So I set my trial for position, velocity, acceleration. You can see that I did that. I let it run for 4 seconds. And now I want to sketch these 3 graphs on the 3 graphs that it gives me right here. So I want to sketch my position graph based on this position graph. So you can see my position graph goes from 0 up to, it actually reads the current position right here. So the current position is 8 meters. So my position graph goes from 0 at time 0 to 8 at time 4, which should make sense because we said the velocity was 2. So over here, there's 2 ways to do this. All right, there's the draw button where it gives you the pens, which is what I have been using. So you just click a pen and then you can use the mouse to draw like that. And I might make a mark right here to let me know that the max value is right around 8. And I'm just drawing with the mouse. I'm not using any like, can you see my hands? You can't see my, well, you can a little bit, but I'm just drawing with the mouse, right? I'm not drawing with anything fancy. So there's that. Another way to do it, if you go to the review tab So not everybody has the draw function, I don't think. But if you go to review, can I see? It's not going to work. It's the same thing. All right, never mind. I lied. They're both the same thing. Draw and inking are the same thing. But you might not have it. If you don't have the draw button, if you go to review over in this right side, it should say start inking. And it gives you basically the same things that the draw tab does up here. So if you don't have the draw tab, you can go to review, and then on the right side, it should say start inking, and you can do the same thing. You can draw on there. So there's my position graph. If I check out the velocity graph, it's a flat line between 6 and 0, but I can zoom in to see if I can see what number that is better. 3.5, 2.9, 2.4. So it's just less than 4, and I've zoomed in as much as I can. So it's just less than 2. And if we look at the number there, we can see that it was 2 the entire time, which makes sense because we didn't have any acceleration, right? Our acceleration changes velocity. If we don't have any acceleration, our velocity should stay the same the whole time. So our velocity was at 2 the whole time, just a straight line. Ooh, that's a rough looking 2, but we do our best. And then acceleration, if we look here, acceleration is right on the x-axis. It's at 0 the whole time. So I'll come back here and right at 0 the whole time. 0. Oh, I don't like that pen. I forgot that I don't like that pen. 0, right along the axis the whole time. So is the man moving to the right or left? Stop that. We answer that question. He's moving to the right. Is the man moving with constant speed or accelerating? Well, the velocity was 2 the whole time, so that's constant speed. And if he's accelerating, was he speeding up or slowing down? He was not accelerating. Right, mostly because we said the acceleration was 0. So that's what we're gonna do, all right? And that's how we do it in Word. That's the easy way to do it. I think Word is the easiest way. If you wanna print it out and do those sketches by hand and answer the questions by hand and then scan it back in and submit it that way works too. If you're gonna use Google Docs or you're gonna convert it to a Google Doc, this is really the only way that I found that you can do it kind of effectively. And you could do this in Word as well. But if you click on the 3 graphs are all linked together. So if we copy those 3 graphs, right? Copy, and we go to Paint. So we open up Paint and we paste the graphs into Paint. We can draw in Paint. What do I want to use? I use them. Oh, that's too thick. All right, we can draw in Paint, and I can draw a line like this, right? A flat line. I probably shouldn't have picked that. That was a bad choice. I should have gone with the colored pencil, right? Velocity was a flat line, and acceleration was at 0. Oops, that was bad. Right, acceleration was at 0. So we could do it that way as well. So you have all 3 of those there. And then we could select all of this, copy it, and then delete that and paste it back in. And I paste it back in, and now it has the things that I wanted on there, right? It's got the position line, the velocity line, and the acceleration line. So that's if you're really having trouble and you're like draw function doesn't work on your computer, or you went to review and it doesn't say start inking there, that's the last kind of way, if you're gonna do it all on the computer, that I've found that you can do those effectively, right? You take the graph, paste it into Paint, do everything you need to do in Paint, and then select it, and then put it back in. So just to show you guys again what I did there to get that right, we can use the pencil to draw. And then once we're finished drawing our graphs, we click the select box. So we click select. We make a little mark or a box around our graphs, just like that. And then we can right click and copy. And then we can paste it into our, delete that, right click, paste into our Word document or Google document, whichever you guys are using. All right, like I said, I think Word document's easier. But if you don't have Word, or you don't have access to Word and you have to do it on Google Docs, you can do it on Google Docs. I will put a link for the Google Doc right below the assignment in the one-dimensional folder. So actually, let me do that right now so I don't forget. So one-dimensional folder, resources, physics. Nope, that's not the right one. Kinematics, accelerated motion. All right, constant motion, Google Doc, add to course. Where's physics? There's physics, one-dimensional motion, add. So now it should be right on our course page, one-dimensional motion, and there it is. There's the Google Doc if you need to use the Google Doc, so you can do that. All right. So just to show you, right, there are, when we go through here, 1, 2, 3, 4, 5, 6, 7 trials. Ooh, actually 8 trials. I renamed this one wrong. That should be trial 8. So there's 8 trials to do, and then 3 analysis questions with a couple parts at the end that I'd like you guys to answer. Hopefully it's pretty straightforward, pretty easy for us. I think I have it due at 11:59 tonight. But like I said, if you're really working on this and doing it quick, you should be able to get it done way before that. All right. Feel free to work with somebody else if you guys want to set up your own like Zoom classes together, or invite each other to Zoom classes and work together. Feel free. I'm cool with that. Obviously, you don't have me to be the kind of connecting resource there. But if you guys want to get together over like FaceTime or Zoom or whatever and work together, that's fine by me. Whatever you need to do to get it done. All right. I think that's it. Enjoy your weekend. If you have any questions, feel free to shoot me probably Schoology message is the best way. I have my phone on me, and I do get notifications when you guys send Schoology messages. So if you have a Schoology message, or if you have a question, send me a Schoology message, and I should be able to answer that fairly quickly. All right. Have a great weekend. Oh, this is going to be awkward as now I try and find the pause button. Oh, no. I found it. Bye, guys.